Alright guys, in this video, one of my viewers actually asked if I could do how to diagnose a CAN issue. So I'm just going to go through the basics. I'm not going to go through anything in depth, but these basics
will lead you on the right direction into locating the fault onto your CAN system.
So the first thing that you got to do when you have well, actually I'll give you a scenario. You have
no communication with your scanner,
and now you have to start diagnosing and you don't know where you're going to start. So the easiest place to start is actually checking your termination resistors. Now your termination resistors, depending on the vehicle make, model, and whatever, will be located into different modules. And for this video, I am using a 2017 Kia Forte, and the termination resistors for this one, I'll try to zoom you guys in. I don't know if you guys see the PCU, which is PCM, ECM, and BCM. And they give you a little legend down here. And those are where your termination resistors are. So, what should you be looking for? That might be your next question. Well, before you actually take and you start measuring, there's one thing that needs to be done, and that's you have
to power down all the modules.
And the easiest way to do that is to come over take your battery and disconnect your battery. So after that, you're gonna have to get a multimeter. You're gonna have to turn your multimeter on, and you're gonna have to set it to resistance or ohms. Now on the circuit, each module has a termination resistance of 120 ohms into the module. Now because it's a parallel circuit, it drops that down to 60 ohms. So the magic number that you're looking for into this circuit is 60 ohms. If you guys have anything higher than that, you might have an issue, maybe a module or an issue with termination resistance or something around there. So first thing we're going to do, or there might just be the module's not on the circuit, so you might have a broken wire or something around there. So we're going to take, and you're going to come down to pins 6 and 14. 6, 14. And you guys are going to come in and you guys are going to connect. And you guys are going to connect onto the other side. Polarity doesn't matter. You can put red wherever you want. And as you can see, I have 62.5 ohms, which is, it's tolerable, it's into the specs. So now let's say if I had a communication fault and I came down here and I didn't have 60 ohms. What would that look like? Well, let's come up to the PCM because that's the easiest one to get to. The BCM's actually underneath the dash. So we're gonna come over. Our PCM's right here. I don't know which connector is which onto these. So we're gonna take and just undo a connector and hope we get the right one. One's gonna be TCM, one's gonna be PCM. So now, connector's undone. Now what type of resistance should we see? This is if you had a communication fault and we got the right one at least. So as you can see, I got a 23 ohms, which is, I said 120, but we're into the specs. So what does that tell you if you read 120 ohms? Well, it means that one of your termination resistors is off the bus, and you have to locate which one that would be. Alright, so I am back at my PCM. This is if you want to check to see if your termination resistor is actually active onto the system of your PCM or BCM. You would actually have to go onto and disconnect your connector. Then you guys would have to take and pin out your the pins inside the PCM. and then you guys could come over and actually see if you have 120 ohms of resistance onto your PCM. Now, if you don't have 120 ohms, then your issue is inside your PCM. If you do have 120 ohms, then your issue is probably somewhere else. So, as you can see right now, I had plugged in my battery and I actually plugged up my the PCM. Now, I'm still connected. Now, if you try to take your resistance without unplugging your batteries, this is what ends up happening. So I don't think that you can actually get a decent reading. You're going to be like, oh no, there's an issue onto the vehicle. When really there's no issue. You actually have to disconnect the power source in order to measure your termination resistance. Just keep that in mind. First step, termination resistance, disconnect the battery. That's all this part's for. So we're going to turn this guy off. And now, I already have the scope all set up. And I am on. As you can see, there's still there's a little bit of communication. There's not very much. Everything's still like asleep, so that's good. So now what we're going to do, we're going to take and we're going to turn the key on. And I'm going to go over some voltages onto there at the same time for you guys. So we're going to turn the key on, and key is on. And now everything is awake. And as you can see, we have a nice looking CAN signal. And the reason that you know that's a nice looking CAN signal, I'm going to take the beat off for a minute. And I want you guys to look at my voltages. Now, your CAN high is going to range between 2.5 up to roughly about 3.5. Okay? So if I would pause this, there we go. And we have a high of 4.2 and a low of 3.7, which is okay. Look, 4.2, it's a little high, but it's not nothing to be concerned about. And as you can see, we have 3.5. So 2.5 to 3.5 is your normal CAN high voltage. Now, we're going to put on the CAN low. We're going to start. And we're going to take off the CAN high. And as you can tell, our CAN low is at the same thing, except for it's going opposite. Let's bring, come on here. There we go. So we're at 2.6, and we go down to a little under 1 volt. And this is where it should be. And 1.2. So typically your CAN high goes from 2.5 to 3.5 volts, and your CAN low goes from 2.5 volts down to 1.5 volts. And that's the way that you would measure your head to know if you have a good looking signal. So if you would ever come and you would see spikes up to like 8 volts on your CAN high, or you would see spikes up to like 8 volts onto your CAN low, well, that means that you have an issue onto your signals. So you would have to diagnose why you have those issues. And hopefully after this video, you'll be able to diagnose that a little bit better. So that's a good looking CAN signal. So we're gonna keep that, and we're gonna work with this now. Now what we're gonna do is we are gonna take these leads off. And just a little note, a module onto a CAN system can also be referred to as a node. So node, module, they're the exact same. So now we're going to take in short our CAN high to ground. Now I'm doing it at the DLC connector just for ease, but typically you would want to test all these at the modules that you have a concern with. So no PCM communication, do all your tests at your PCM. Do not do them at the DLC. The DLC is more just a quick check to give you an idea of what's going on, but you actually have to go to the modules. So with that being said, now we're going to short our CAN high to ground, and that's the short to ground. All right, so This is what a short to ground looks like onto your can low, on your can high. And we'll take away as you can see, a short to ground will actually bring you down to 0 volts because you're short to ground. And what does it do to your can low? Now, as you can see right here, your can low is also shorted to ground because there's still communication on the can low side, but it's not communication that can actually be used or interpreted by any of the modules. Just keep that in mind. So your can low gets shorted to ground, and your can high gets shorted to ground. When your can high gets shorted to ground, now we're going to take and we're going to short the can low to ground. We'll wait for our module communication to return. Normally it happens pretty quick. Okay. Now we're going to take our can and short our can low to ground. So, as you can see right here, our can low got shorted to ground, but we still have communication onto our can high. But if you can see right here, remember those magic numbers I told you, that your can high and can low have to be at 2.5 volts. If you see here, I am at 0 volts on both, and then I'm shooting up to 2.5. So I do have a communication issue. You guys have to make sure that you're between 2.5 volts onto your can low and your can high as a starting point, and then your can low will drop voltage down to about 1.5 volts, and your can high will go up to about 3.5 volts. Keep that in mind. So now what we're going to do, we're going to come over, bring back some communication. Like I said, communication does get restored pretty quickly. So now we're going to come over and we're going to short out to positive, and we're going to do the exact same thing. Now, when you guys have a short to positive on your can system, yeah, it doesn't like that. Okay, short to positive. Ooh boy, huh? So we're gonna put this onto a 20 volt scale, so we're able to see everything. All right. So as you can see, now I'm shorted out to battery voltage. Okay. Now as you can see, the can high is actually staying at 12 volts, which is what the battery's at. The battery's kind of weak right now. But if you look at your can low, it's still at 12 volts, but as you can see, it's actually trying to drop down to its working parameters. So this is what a short to voltage looks like onto a can high system, on your can high line. Now we're going to go and do the low side, and we're going to see what happens when we short the can low out to positive. Okay. So can low shorted to positive, both get shorted out to battery voltage. But as you can see, my can low is completely shorted out, where my can high is still trying to communicate. And you can see that by the spikes that are happening into the system. So when your can high gets shorted out to battery positive, you will see no communication on that line. When your can low gets shorted out to battery positive, your can high will still try to communicate. When your can high gets shorted out to battery positive, your can low will still try to communicate. So it gives you a good indication on what line might be having the issue. So now what we're going to do is actually short both can systems out together. So we'll restore our communication. And now we're going to take and short out our can high to our can low. And as you can see, what ends up happening, they cancel each other out. So with them being canceled out, well, now there's no communication whatsoever onto the bus. And if we go and we measure, I'll just give you guys a quick measurement. We are at 2.5 volts. And remember that magic number I told you guys? of 2.5 volts. Well, that's what we're at, 2.6, 2.5 roughly. That's what ends up happening when your CAN system shorts out together. Now this could be happening from wiring, module, erosion, anything like that.
So I hope you guys enjoyed this little video, and if you did, please like, subscribe, and comment, and I will see you guys next time.